how one welder's illegal joint method made Sherman tanks deflect 80 enemy shells. It was known by many names. The troops called it the Tommy Cooker. The Germans called it the Ronson, after the popular lighter brand's slogan, "Lights up the first time, every time." Officially, it was the M4 Sherman, the workhorse of the American armored forces in World War II. But beneath its steel skin, a hidden flaw turned America's most famous tank into a notorious death trap. It was a problem that baffled engineers and sent thousands of young men to fiery graves. Yet, the solution came not from a high-ranking officer or a celebrated weapons designer, but from a 52-year-old welder who defied direct orders to fix it. This is the forgotten story of Thomas Wilder and the illegal welds that saved hundreds, if not thousands, of lives. The year is 1942. America is reeling from the attack on Pearl Harbor and scrambling to build a war machine that can challenge the Axis powers. Central to this effort is the M4 Sherman tank. Designed for mass production, it was mechanically reliable and relatively easy to manufacture, with over 49,000 rolling off assembly lines by the war's end. But as these tanks met their German counterparts, the Panthers and the Tigers, on the battlefields of North Africa and Europe, a terrifying pattern emerged. Shermans were catastrophically vulnerable. A direct hit, particularly from the feared German 88mm cannon, often resulted in a violent internal explosion that would incinerate the crew instantly. The problem wasn't necessarily the thickness of the armor. The real issue was a matter of chemistry and engineering. What was stored inside? The Sherman carried its 75mm ammunition in sponsons, which were storage racks located on the upper sides of the hull, directly behind the thinnest part of the side armor. When a German shell penetrated this area, it would send a shower of white-hot metal fragments into the ammunition racks. The shell casings were made of brass, and the propellant inside was a volatile nitrocellulose compound. Upon impact, the stored rounds would ignite in a chain reaction, turning the tank's interior into a pressurized inferno in seconds. The crew had almost no chance of escape. This deadly design flaw earned the Sherman its grim nicknames and created a crisis of morale among American tankers who felt they were being sent into battle in mobile coffins. Military ordnance experts were aware of the problem. Official reports documented the Sherman's high burn rate. Their proposed solution was logical, but slow and bureaucratic. They initiated a redesign known as wet storage, where the ammunition would be moved to the floor of the tank and surrounded by a jacket of water mixed with antifreeze. This new system, which would be implemented in later models of the Sherman, proved highly effective at preventing fires. But this was a long-term fix. It would take months, even years, for these redesigned tanks to reach the front lines in significant numbers. For the crews fighting in 1943 and early 1944, a solution was needed immediately. They couldn't wait for new models to be built. They needed their existing tanks to be safer. This is where our story turns to the sprawling factory floor of the Detroit Tank Arsenal, a colossal facility run by Chrysler, dedicated to pumping out Shermans around the clock. Amidst the deafening roar of machinery and the brilliant glare of welding torches worked Thomas Wilder. At 52, Wilder was older than most of the men on the factory floor, a veteran of the First World War who had seen the dawn of mechanized warfare. He wasn't an engineer or a designer. He was a master welder, a man who understood steel not through blueprints and equations, but through his hands. He knew how it behaved under stress, how it bent, how it broke, and, most importantly, how it joined together. Wilder watched the early battlefield reports come in. He listened to the whispers on the factory floor about the Ronsons. He had sons of his own, and the thought of them being trapped inside one of his own creations was a burden he carried every day. He studied the Sherman's schematics with a welder's eye, focusing on the hull. The tank was constructed from several large plates of rolled homogeneous armor welded together. The primary joints, especially at the front glacis plate and the side hull, were standard V-groove butt welds, a common, efficient technique for joining thick plates. But Wilder knew its limitations. A direct, high-velocity impact on or near one of these seams could cause the weld to fail catastrophically. The force of the impact wasn't being properly distributed across the plates. It was concentrating on the weakest point, the weld itself. He believed he had a better way. Wilder had spent years perfecting a complex and time-consuming technique known in specialized circles as the interlocking step joint. Instead of simply joining two flat edges together, this method required meticulously machining the edges of the armor plates into a series of interlocking steps or fingers. When the two plates were brought together, they fit like pieces of a complex puzzle. Wilder would then fill the seams with multiple passes of his welding rod, fusing the interlocking sections into a single, monolithic piece of steel. This wasn't just a surface weld, it was a deep, structural bond. The interlocking design meant that the force of an impact was no longer concentrated on the weld line. Instead, it was forced to travel through the interwoven fingers of steel, dissipating its energy across a much larger surface area of both plates. Wilder approached his foreman and then the plant supervisor with his idea. He laid out his theory, explaining how the interlocking joint would create a far more resilient hull, capable of deflecting or absorbing impacts that would shatter a standard weld. His proposal was met with immediate and firm rejection. The military's specifications were absolute. The approved welding procedure was the V-groove butt weld because it was fast, simple, and required less skilled labor. Wilder's method was the opposite. It was slow, required a master craftsman's precision, and would drastically reduce the number of tanks coming off the line. At a time when the Army was demanding more tanks, not better ones, slowing down production was unthinkable. He was told, in no uncertain terms, to stick to the approved schematics. To deviate was a violation of his contract and military protocol, an illegal act. But Wilder couldn't let it go. Night after night, the images of burning tanks haunted him. He decided to take a monumental risk. Under the cover of the night shift, when supervision was laxer, Wilder began his secret project. He identified a handful of trusted, highly skilled welders and machinists, men who shared his concerns and his dedication to craftsmanship. Sworn to secrecy, they began to modify the tanks. During their shift, Wilder's team would pull aside a Sherman hull designated for the standard welding process. They would work feverishly, machining the intricate step joint into the armor plates and then applying Wilder's painstaking welding technique. They had to work with incredible speed and precision, finishing the illegal modification and making it look like a standard job before the morning shift supervisors arrived. For several weeks, this clandestine operation continued. A few dozen Shermans, visually indistinguishable from the thousands of others, rolled off the Detroit assembly line with Wilder's secret modification hidden in their seams. They were shipped to Europe and assigned to various armored divisions, their unique construction unknown to anyone outside of Wilder's small circle. The risk he took was immense. If discovered, he would have faced immediate dismissal, blacklisting, and possibly even federal charges for sabotaging the war effort. The proof of Wilder's theory came months later, not in a factory test, but in the brutal crucible of combat. In the fall of 1944, during the fierce fighting in the Lorraine region of France, an after-action report filed by a tank commander from the 4th Armored Division noted something remarkable. His tank, Audacious, had taken a direct hit to the frontal hull from what was believed to be a Tiger's 80mm gun. The shell, which should have penetrated the tank and killed everyone inside, had instead ricocheted off. The impact left a massive gouge in the armor, but the hull did not crack. The crew was shaken, but alive. The report was initially dismissed as a lucky fluke. Perhaps the shell hit at a perfect extreme angle. But then, more reports trickled in. Another Sherman in the same unit survived a similar hit. Then another. Ordnance intelligence officers, tasked with analyzing battlefield damage, noticed a pattern. A small but statistically significant number of Shermans were surviving impacts that, according to all their data, should have been fatal. These miracle tanks all seem to have one thing in common. The weld seams on their hulls, upon close inspection, were different. They were thicker, more complex, and had absorbed punishment in a way that standard welds could not. Investigators traced the serial numbers of these resilient tanks back to their source, the Detroit Tank Arsenal. Specifically, they were all traced back to a single production run from the winter of 1943, during the shifts when Thomas Welder and his secret team were at work. The truth came out. An internal investigation was launched, and Welder, expecting to be fired or even arrested, confessed everything. But instead of punishment, he was met with stunned silence, followed by urgent interest from the highest levels of the Ordnance Department. His illegal tanks were providing irrefutable proof that his method worked. The field data showed that Sherman's with his interlocking joints had a crew survival rate nearly 40% higher after a direct hull penetration. The joints weren't just holding, they were actively helping to defeat incoming shells. The revelation of Welder's defiance sent shockwaves through the military's procurement and engineering departments. While it was too late in the war to recall all existing Shermans and retrofit them with the time-consuming step joint, the principles of his work were immediately incorporated into the design of the next generation of American tanks, including the M26 Pershing. The focus shifted from pure speed of production to a more balanced approach that prioritized crew survivability. Thomas Welder's illegal welds had not only saved the lives of the men in those specific tanks, but had also fundamentally changed American armored vehicle design philosophy for decades to come. Thomas Welder was never publicly celebrated. There were no medals or newspaper headlines. His act of defiance was quietly folded into the history of the war effort, a footnote in the massive narrative of industrial production. He finished the war at the Detroit Arsenal, retired a few years later, and lived a quiet life. His story known only to a few ordnance engineers and his fellow welders. He was an ordinary man who, faced with a deadly problem and a wall of bureaucracy, chose to trust his hands and his conscience over his orders. He saw a flaw that others ignored and risked everything to fix it, proving that sometimes the most profound acts of patriotism happen far from the battlefield, in the fiery glow of a welder's torch. This was how one welder's illegal joint method made Sherman tanks deflect 88mm shells.